Lesson 1, Key Features of Functions. My essential question is, how do graphs and equations reveal information about a relationship between two quantities? Okay. So these are the items that we're actually going to cover in this lesson. So I'm going to talk about domain and range, x and y intercepts, positive and negative intervals, increasing and decreasing, average rate of change, and summary. Okay. So domain and range. So the first thing we're going to talk about is domain and range. So domain is your x values. They're things that you're putting into an equation, so your inputs. So the domain of a relation is the set of all inputs or x coordinates, okay? Your range is your outputs or your y coordinates. The range of a relation is the set of all outputs or y coordinates. So one easy way to remember this is Dix-Roy. So DIX, domain inputs x coordinates, Roy, ROY, range outputs y coordinates. So example, what is the domain and range of the function defined by y equals x squared minus 3? So if we're looking at this, right, we're looking at this equation right here. So we're looking at this graph that they gave us. Okay, so this graph, basically, I'm looking for my x values. So if I'm looking at this, okay, so if I'm looking at this, I'm looking at just my x values. So my x values, and it's going to go off the page. So it looks like it's starting at -3, but again, it's going off the page. It's going towards negative infinity. Okay. I'm going to keep going. I have all of these x values, and it's going to go towards infinity. Okay. So I can pick any x value that I want, and it will be on the graph. Okay. I can only pick y values that are greater than -3, though, because if I look at this minimum point, this lowest point that I have on my graph, there's nothing lower in that graph. So if I look down here at -4, I can't use -4 as a y because it's not on my graph. It's not in the equation, okay? So if I pick a value that is less than -3, it won't be on the graph, okay? Set builder notation. Set builder notation uses a verbal description or an inequality to describe the numbers. So as you can see here, I've got the name of my set. Okay. Name of the set, my element. That bar means such that, and then the criteria for X to be in S. Okay, so for example, with that last one we were looking at, my domain is going to be all real numbers. It's going to be negative infinity until I get to positive infinity. My range, however, is anything that's greater than -3. So we've got that y such that y is greater than or less than or equal to -3. Okay. Interval notation. Okay. So there are two different ways. Interval notation is the other way that we can write it. Interval notation represents a set of real numbers by the pair of values that are its left minimum and right boundaries. So left is your minimum boundary, your smallest number that you can have. Right is your maximum boundary or your largest number you can have. Okay, the other thing to notice here is parentheses means that that point is not included, while a bracket means the point is included. So if I was looking at the example that I had previously had, okay, my domain was going to be negative infinity into infinity. So that's all the x values that are there. My range is from -3, and there's a bracket, okay, because that -3 is included towards infinity. So as I'm going, I start at -3, which is my minimum point, and I'm going up and up and up and up and up. So I'm going towards infinity. So again, this is an example of interval notation and set builder notation, and you're talking about different numbers. There's brackets versus parentheses. One thing to note is that parentheses will always be used for infinity, negative infinity and positive infinity. They'll always be used for those. Okay. X and Y intercepts are also known as zeros of the function. So basically it's anywhere where that function is going to be 0. So I want to find the X and Y intercepts. So what are the X and Y intercepts of Y equals the absolute value of X minus 3? The first method to do is just graph it. Okay, so you can use Desmos. It's a great website, and I'll link Desmos in your Google Classroom. So basically what I'm looking for is I'm looking for anywhere that it crosses an axis. Okay, so in this case, my x-intercepts are these points right here where it's going to cross the x-axis, and my y-intercept is where it crosses the y-axis. Okay, method 2, you can substitute zeros in for x and then zeros in for y. Okay, so if I do that, I'm gonna find my x first. So I put a 0 in for y. I add 3 to both sides. X, 3 equals the absolute value of x, which means x can be plus 3 or minus 3. Okay. For y, I do the same thing, except I put a 0 in for x. So y equals negative 3, my y-intercept. Okay. So my x-intercepts, again, are plus 3 minus 3. They cross twice across that x-axis, while my y-intercept, there's only one at negative 3. Okay, positive and negative intervals. So positive and negative intervals, we're talking about, is it above or below the x-axis? So for what intervals is f of x equals x squared minus 9 positive? For what intervals is the function negative? Okay, so first thing I'm going to do is I'm going to graph this. Okay, so I'm looking at this graph right here, and I want to identify, okay, so the first thing I want to do is I want to find the x-intercepts. Okay, when I do that, that's going to help me figure out what's positive and what's negative. So again, positive's anything above the x-axis, negative's anything below the x-axis. So I can determine, again, if it's above the x-axis, it's positive. So it's above this pink part right here, okay, from negative infinity until I get to negative 3, and then from 3 until I get to infinity. Okay, so the x-intercepts are x is less than negative 3 and x is greater than positive 3. Okay, so that's where it's positive. Okay, then I'm talking about negative and it's below. So this teal part below the x-axis does not include the x-intercepts. So in this case, there's just one because it's not broken into sections. So I've got negative 3 to positive 3. Increasing and decreasing of functions. So again, if you're increasing, decreasing, you want to kind of think of like you're on a roller coaster and you're always going from your left to right. So if I'm going up the roller coaster, I'm increasing. If I'm flat, I'm constant. And if I'm going down, I'm decreasing. So again, for what values of x is g of x equal negative 1/4 x squared plus the absolute value of x plus 3 increasing? And for what values is it decreasing? Okay, so I want to graph the function first. That will make my life so much easier if I just graph the function. Okay, once I do that, I've got this almost like a McDonald's sign shape. Okay, so I'm thinking about it. I'm starting from this side right here. So I'm starting from my left to right. I'm going up. I pass the x-axis. So I'm increasing, 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 increasing until I get to this very top point. And then I'm going to decrease till this point, then I'm going to increase again, and then I'm going to decrease again. Okay. So I want to identify maximum and minimum points. So something else to think about here is global maximum are the greatest value of a function, so the highest point. So in this case, I have 2 global maximums, which are negative 2, 4, and 2, 4. And then I can have a local maximum or another high point on the graph. It's not necessarily considered a low point. Your global minimum is the least value of a function, so the very lowest point. I don't have a global minimum here. I have a local minimum, which is another low point on a graph. Okay. Local maximums and local minimums can kind of be interchanged. It just depends on how you really look at the graph. So in this case, I'm looking for any like key points in the graph. So I'm looking for dips or I'm looking for peaks. Okay. Next, I'm going to determine increasing and decreasing. So again, I'm increasing until I get to that point, decreasing, then increasing again, and then decreasing again. So I'm increasing from the lowest point, in this case, negative infinity, because it's going off that graph, and you're only worried about the x points. You're only worried about x coordinates. So I'm increasing from negative infinity until I get to -2. At -2, I'm going to switch over and I'm going to decrease. Okay, so from -2 until I get to 0, I'm decreasing. And then again, I'm going to switch 0 to 2, I increase again. And then from 2 till negative infinity, I'm going to decrease. Average rate of change. Okay, so this is the exact same process as finding slope. You're going to take your rise over your run, okay, or your y values over your x values. Okay, so what do the average rates of change over the intervals -2, 0, 0, 3, and -2, 3 tell us about the functions? So the first function I'm looking at if f of x equals 1. So it's just this straight line. Okay, so I put the points on the line to mark the intervals that I'm measuring. So I'm measuring at -2, at 0, and at 3. Okay, again, I'm only using my x points to figure out where I am on the graph. Okay, so I'm going from -2 to 0. I'm trying to figure out the rate of change or the slope. If I'm looking at this, I can label my points. I find the average rate of change. So I subtract my y values. In this case, 1 and 1. So 1 minus 1 is 0. And I subtract my x values, 0 minus -2, which is +2. And then I find my ratio of 0 over 2, my y over my x. Okay, it's the exact same thing that you do for slope. Your 2 y values, subtract them. Your 2 x values, subtract them. Change in y over change in x. That's what this little triangle symbol means. It's delta in Greek, but it means change of. Okay. So I find the average rate of change from interval 0 to 3. Again, it's going to be 0. And I find the average rate of change from -2 to 3, which again is 0. Okay. The entire average rate of change over all of them is 0. It's a constant rate of change, and it's a constant rate of change that is 0, which means it's a constant function. Okay. So again, I'm going to do the same thing. This is slightly different. Okay, so I have f of x equals 1/2 x minus 1. Okay, so again, I'm finding that average rate of change over the interval from -2 to 0. Okay, so if you can look, you can also look at this and go, okay, well, I went up to 1, 2, 3 over 4. 2/4 is the same thing as 1/2. Okay, 1/2. Okay, I can do the same thing from 0 to 3. I went up 3 over 1, 2, 3, 4, 5, 6 over 6. 3 divided by 6 is 1/2. Okay, and I can find the whole average rate of change from -2 to 3. So again, I went up to 1, 2, 3, 4, 5. So I went up 5 and then over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 divided by 10, again, 1/2. So this is a constant rate of change, but it is a constant rate of change that is a specific number other than 0. So it's a straight line or a linear function. So again, I'm going to do the same thing with a quadratic function or an x squared. Okay, so anytime we're talking about a quadratic function, we have that little 2 somewhere in that equation. So the subscript, the superscript 2. Okay, so again, I'm going to put the points on the line. I'm going to label my points. I'm going to find the average rate of change. Okay, so I can do the same thing where I can count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 8 divided by 4, and I went down, so -2. I can do the same thing from 0 to 3, or I can just subtract them. 9 minus 0 is 9. 3 minus 0 is 3. 9 divided by 3 is 3. And I do the same thing from -2, 4 to 3, 9. Okay, 9 minus 4 is 5. 3 minus -2 is 5. 5 divided by 5 is 1. Okay. So I noticed that my average rates of change in this case are different. There's no constant rate of change, which means it's a non-linear function. So a linear function literally just means it's a line. Okay. So anything that's not a straight line is a non-linear function. So anytime I have a U or a W shape or anything like that, it's a non-linear function. Okay. So in summary, again, I've got linear, quadratic, absolute value, and constants. My domains for all of these are really going to be negative infinity to positive infinity. And in general, that's what most of your graphs are going to look like. They're going to look like that negative infinity to positive infinity domain. Your range is really where you're going to have to think about, okay, where does it stop? Where does it start? Is there a specific point that I'm going to but not going past? Okay, so linear, usually your ranges are negative infinity to positive infinity, again, because it's that straight line. Okay, quadratic and absolute value, you're going to think about where it's going to stop. Okay, and again, a constant it's just one number. You can only have one choice. So it's not going to be negative infinity to positive infinity. It's going to be whatever that y value is for that constant number. Okay. Increasing and decreasing, remember, think about it like a roller coaster. And then x-intercepts, y-intercepts. Okay, so wherever it crosses the x-axis, wherever it crosses the y-axis. You can have 2 x-intercepts, you can have 1 x-intercept, or you can have no x-intercept. Usually you will have a y-intercept, but you're not necessarily guaranteed to have one. And that is the end of Unit 1, Lesson 1.